Hello, my name is Prince Obajowo Daniel Nicole, also known as the Morpholic Arithrophysical Biologist. It is high time we started the class. So today we'll be talking about atomic properties and periodicity. Yes, and these properties or periodicity of atoms include atomic radius, ionization energy, electron affinity, and electronegativity. So let us start with the first one, which is the atomic radius. What is the atomic radius? Atomic radius is the half distance between the nuclei of two covalently bonded identical atoms. For example, the distance between the nuclei of a carbon-carbon bonded atoms, as you can see it here. Or better still, we can say it is the measure of the size of an atom. Now, to understand what I'm saying clearly, let us consider this carbon-carbon bonded atom. Remember that carbon has atomic number of what? 6. On that note, its electronic configuration is 1s2, 2s2, and 2p2. Now, it is an established fact that the valence electrons of elements are responsible for the reaction for bonds to be formed. On that note, the electrons found in the second shell, that is these 4 electrons, will be the one that will react. On that note, the last shell, which is the valence shell, will be the bone of contention. Now, if we draw the last shell of the 2 carbon atoms and consider the distance between the center, which is the point where we have the nucleus, and the valence shell, that is the circumference. The distance between that center and the circumference is the atomic radius of this carbon. On the other hand, the distance between the circumference and the center, which is where we have the nucleus, is the atomic radius of this carbon. So which means that the length that is denoted by A is the atomic radius of the carbon, so to say. So looking at this, we can say that the atomic radius of an atom is a measure of the size of such atom. But then what happens to the trend of elements across the period of a periodic table and also down the group? On that note, I would like us to pay close attention to these vital points. Atomic radius increases down the group. You may ask why. So to understand that fact, let us consider some group 1 element, that is lithium, sodium, and potassium. Let us consider their shell diagram to actually understand why atomic radius of elements increases down the group. Now we know that lithium has atomic number of what? Of 3. And the electronic configuration is what? 2, 1. Now let's draw the shell. In the first shell, which is the K shell, we are going to have 2 electrons, as you can see present here. And the last shell, which is the second shell, we are going to have only 1 electron. Let me draw the other 2 elements electron to actually see what actually happens when we compare the shells. Now looking at sodium atom, sodium has atomic number of what? 11. And the electronic configuration with respect to the shell diagram is what? 2, 8, 1. Can you see that? So let's draw the shell. We have 2 electrons in the first shell. We have 8 electrons in the second shell. And we have 1 electron in the last shell. Can you see that? Now let's draw the last one. We have potassium, which is the 19th element, that is with the atomic number of 19. And the electronic configuration with respect to the shell diagram is what? 2, 8, what? 8, 1. Can you see that? So let's proceed. So drawing the shell diagram, we have 2 here, 8 here, 8 here, It follows. I believe you are following through. It follows. And the last shell has only one electron. Now, remember I said that atomic radius increases down the group. Why? If you look at what happens down the group, looking at the first element here, which is lithium, you will notice that the distance between the center where the nucleus is and the circumference, that is the distance between the center and the valence shell, you will notice that it is shorter than the distance between the center of sodium and the valence shell. Can you see that? Also, if you look at the last one there, the distance between here and the valence electron is larger. Now, if you look at what is happening here, lithium has a smaller atomic radius. Can you see? Sodium has the one bigger than that of lithium, while potassium has the largest or the biggest atomic radius when comparing these three elements. Now, these three elements, lithium, sodium, and potassium, are some elements in the group 1 family when you consider it down the group. So looking at what I just said now, you notice that the atomic radius increases from lithium to sodium and to what? To potassium. On that note, you can actually see that the atomic radius increases down the group. Are you following through? Now, another point you need to consider when it comes to atomic radius is the fact that atomic radius decreases across the period. Yes. Now, for us to understand that, let us consider these three elements found in period 3. Sodium. We know that sodium has atomic number of what? 11. And with the electronic configuration with respect to shell to be what? 2, 8, 1. Now, if you draw the shell, we have 2 here. We have 8. And we have 1 at the last shell. Now, looking at the next one, that is magnesium with the atomic number of 12. And the electronic configuration with respect to shell, that is 2, 8, 2. I believe you are following through. We have 2 here, 8. And the last shell has 2 electrons. What about the last one here, which is aluminum? Aluminum is with the atomic number of what? 13. And the electronic configuration of 2, 8, 3. Drawing the shell, we are going to have 2, 8, and 3. Now, looking at what we have here, you notice that the number of shells we have across the period here remains the same. The only difference is that the number of protons increases across the period. And as such, since the number of protons increase across the period, the nucleus tend to draw electrons closer, thereby reducing the radius. Are you getting what I'm saying now? Of the atom when you move across the period. Can you see that? That is, looking at the number of protons, the number of shells we have here, we have 3, 3, 3. And that actually determines period 3 in this case. But then, looking at the number of electrons we have here, or number of what's called protons we have, since the atom is stable or the atom is neutral, we have 11 protons here, 12 protons here, and 13 protons. Now, there's an increase in the number of protons. As such, there will be tendency for the number of protons as they increase to drag electrons closer to the nucleus as the number of protons increase. As a result, that brings about reduction in the size of what? Of the atom. So since the size will reduce from here to here to here, that factor is a factor of what? Atomic radius. So we can categorically say that atomic radius decreases across the period. Don't forget, I still remain your tutor, Prince Obajowo Daniel Dinicole, also known as the Mathaholic Arithmophysical Biologist. Stay tuned.